Let's look at another twist on these types of problems. So let R be the region bounded by y is equal to x squared plus 2 and y is equal to 4 minus x squared. Find the volume of the solid obtained by rotating R about y is equal to minus 3. So here's our new twist. We're not rotating about the x-axis. We're rotating around a different horizontal line. Okay, so the first thing to do, let's figure out what exactly is this region that we are rotating around. What does it look like? So y is equal to x squared plus 2. That is an upward opening parabola. Something like that. Y is equal to 4 minus x squared. That is a downward opening parabola. And so this region, that's the region that we're rotating here. Now, in order to figure out, we really care about what are these x values here. So in order to find those, we need to set x squared plus 2 equal to 4 minus x squared. And now solving this for x gives us 2x squared is equal to 4 minus 2 is 2. X squared is 1. X is plus or minus 1. So this x value here minus 1, this x value here is plus 1. That is what the two x values that we're going to integrate between. So just to remind us, here is the setup for the washer method. So minus 1 and plus 1 are those two, are the two values there for a and b. Let's write this down. V is equal to pi times the integral from minus 1 to 1 of stuff. And so now the tricky thing is, well, we have to figure out what is this R out and what is this R in our calculation. Okay, so we are rotating about the line y is equal to minus 3. Now usually, like in the previous section, we have been doing y is equal to 0. That's the x-axis. So now we're dropping down to, here is y is equal to minus 3 is someplace down here. This is what we're rotating around. Okay, so what does this say? What does this say about what the R out and R in are in this situation? So R out, the outer radius, is going to be all the way from here all the way down to here. Now, this part, that is just going to be 4 minus x squared, but then we add on 3 more down here because we're rotating around not y is equal to 0, but y is equal to minus 3. So this whole thing is 4 minus x squared plus 3, so that's 7 minus x squared. And so that is going to be our R out. And so when we square that, we end up with 7 minus x squared. And all of that squared there. Now we have to figure out the inner radius and subtract off the square of the inner radius. And so that goes in very much the same way that here, that distance is going to be x squared plus 2. But we also have to add on 3 more here in order to get all the way down to y is equal to minus 3. Okay, so what we end up with then is going to be, x squared plus 2 plus 3. And so that is going to be x squared plus 5. And then, of course, we have to square that. So we can see here that this formula matches this pattern down here. V is equal to pi times the integral between a and b of the outer radius squared minus the inner radius squared. So this is the setup. The rest of this is going to be very easy to compute. I'll just do a couple steps here. This, of course, is going to be 49 minus 2x squared plus x to the fourth. And this is going to be x squared plus, oh, that's not a 2x squared. That is going to be a 14x squared. This is x squared plus x to the fourth plus 10x squared plus 25. And when you do this minus this, you end up with minus 1 to 1 of, you end up with 24 times 1 minus x squared. And that's pretty easy. I'll just say your final answer then is 32 pi. Like so many problems in this section, the really important thing is coming to the setup here. Actually evaluating this integral is a pretty straightforward process. I care about, can you get to this setup?